Hi everybody, welcome to the Manifold channel. Today we're going to use the join dialog to convert a vector drawing into a raster image. This is a classic vector to raster conversion. And we're working with Manifold System Release 9, which is what you see in front of you right now. All this works in the free viewer as well, so you can download the free viewer and try it out at home. And what we're going to work with is this drawing called land cover. If we look in the project, there it is right there. And the land cover drawing shows a region in New Zealand where there's a bunch of area polygons that cover it, and each area polygon is encoded with a attribute field that codes for a so-called classifies. It says what type of land cover it is. If we pop up the land cover table, we can see how it's arranged here. This is from the New Zealand government, and they have classifications as were used in '96 through 2012. So, for example, this one right here, classification 240 in 2012 meant a high-producing exotic grassland. So what we're going to do is we're going to create a raster which has equivalent detail to this, and in the raster all the pixels are going to acquire a code number which is the same as a classification code. So based on the value of the pixel you can tell what type of classification it is, what type of land cover that is. So the first thing we're going to do is I'm going to zoom to fit, and what we want to do is we want to decide how big a raster do we want to use, because it makes a difference whether we have our pixels are 1 meter in size or whether our pixels are 10 meters in size. Because when pixels are 1 meter in size, if we covered this large area, that could end up being a very large raster. So the first thing we want to do is we probably want to get an idea of the extents of the drawing that we're working with. And I'm going to use the tracker for that. So I'm going to click on tracker, and then I'll click here on approximately the left side of it, and then here on the right side of it. And you can see down in the lower left corner, the tracker tells us that's about 59,000 meters wide. So let's say 59 kilometers wide. And right click and choose clear tracker, and now I'll choose look from the upper part to the lower part, and we can see that's about 50,000 meters tall. So we're looking at a region which is roughly from roughly 59 kilometers by 50 kilometers in size. So how big do we want to make individual pixels? To do that, let's kind of zoom in here where we see some details. And here's a detail right here that we can look at. And if we measure some of the features here, for example, using the tracker, let's measure this, and we can see, click and click here, that's about 12 meters, 13 meters, something like that. So as a rough estimate, if we make pixels that are about 10 meters in size, that should do a pretty good job of capturing all this, and that's only going to end up in being a raster which is roughly 5,900 by 5,000 pixels in size. I'm just taking the extents in meters and dividing them by the size in meters of the pixel. So divide by 10, from 59,000 you get 5,900. Divide 50,000 by 10, you get 5,000. So that's a reasonable size raster. So that tells us about what we should use in terms of pixel size. Let's give that a try. Let's give this process a try with pixels that are 10 meters in size. All right, so the first thing I'm going to do is I'm going to create a drawing. Now before I do that, what I'm going to do is I'm going to save the projection of this, because I want to create an image right now which is the same projection as my land cover drawing. And the easiest way to do that is to go here to the components pane, and here this tells you that this is in New Zealand transverse Mercator projection. Great, let's copy that. So I've just copied the coordinate system. So now when I go into the project, I can right click and choose create new image, and the first thing I'm going to do in the new image is I'm going to click on here and I'm going to choose paste. So I've just pasted the coordinate system for the new image to use. It's that easy to create a new component, new image or drawing or whatever that uses exactly the same projection as something else. And let's call this new image that we're creating here raster land cover. There, and the type of tile, since I know those classification codes are integers, let's make it in 16. And now I have to do something tricky. I have to specify the size pixels that I want, and unfortunately there is no absolutely a simple way of doing that, except for going into the full coordinate system dialog. Here what I did is I clicked on the coordinate system picker, then I clicked more to go into the coordinate system dialog, then here into custom. I'm going to customize this to change the local scale in the metrics, and I'm going to right click on the metrics picker, click edit, and then here I'm going to make the local scale X is going to be 10 meters and the local scale Y is going to be 10 meters. I've just told it in this projection for this image, use pixels that are 10 meters wide by 10 meters high. That's 10 meters, X is width and Y is height. So let's click OK here. And now let's create this new image. Is everything the way I want it to be? Yeah. I don't care about the bounds because the join dialog will set those for me. Create image. Great. So I've just created the image. I'm going to drag and drop it into the map. The image is blank. It doesn't contain anything. But we need to have everything that we're working with in the join dialog in the same map, so it knows where to find things. Okay, so we have the land cover drawing in the map. We have the raster land cover image. Let's now transfer the values of these areas into the pixels in the raster land cover image by using the join dialog. I'm going to click Edit Join, and here's my target, raster land cover, and my joined component. The drawing is going to be land cover. I just picked that. So what we're going to do is we're going to modify all pixels that are contained within the geometry of various areas in the land cover. Raster land cover has only one channel to it. It's channel 0. And here let's choose the field that we want to join to that. It's going to be classification for 2012. And the transfer mode that I want, I'm going to use the maximum. Now why this matters is suppose we have more than one area that overlays the same pixel. We have to know how to transfer the value from class 2012 into channel 0. And our choices are the count, which we don't want the count of the number of overlapping areas. We can use the maximum, the minimum, or the sum. I'll just use maximum. It doesn't really matter if whether I use maximum, minimum, or sum if there's only if areas don't overlap. And here what I want to do, I want to check the clear image pixels box so that we're going to clear the image before we load it, so that where there aren't any areas in the land cover, there's going to be nothing but null values. And I want to resize the image. I want the join dialog to automatically compute what the size image should be if I'm using 10 meter pixels to cover the extent of this drawing. So now let's click Join Component, and we'll see how quickly it works. Some of these areas here, by the way, as you can see, are fearsomely complicated areas. So this is the sort of procedure which could take many minutes, if not hours, in some other GIS packages. But in Manifold, it happens very quickly. I probably should have launched the task manager so you can see that it used all threads available. It did the join in fully parallel. And what we're now looking at here is the raster land cover image seen in default formatting. I'm going to turn off the land cover layer so you can see we're just working with the image here. And now let's style this to make this pretty, like the land cover drawing. And to do that, I'm going to click on Contents. I'm going to click here on Style. And if there's only one channel, so I'm going to use channel 0. And what I want to do is I want to use unique values, and up to 100 unique values. I'm going to enter that. Now I'm going to click Tally, because each of the codes here is unique, and there's only so many of them. I think there's only 43 of them total. And to color these, let's use a thematic format. I'll use the classic thematic format, the land cover format, which is that. And what I will do is I will reverse that. Look into the style topic in the user manual, which everybody should be reading, by the way, the user manual, because anything you want to know about how any of this stuff is done in depth, just drill into the user manual. It's all there, typically with step-by-step dialogues. And let's see, what else do I want to do? I want to reverse this interval and this interval, because those are really close to each other. And this will help them stand out a little bit better in the resulting dialog. So this is exactly the same thematic format that was used in the land cover drawing. Let's click Update Style, and there, we've just updated the raster land cover. So far we've taken the vector land cover image, the vector land cover drawing, which here it is right here, and we've turned that into an image, a raster image right here, and there it is right there. I'm going to turn off the land cover drawing, just work with the raster land cover image here. Let's zoom into here so we can zoom to some closer spots. This is roughly where we were working at before. And what I will do is I'll turn the raster land cover drawing back on, so I can now click off and on the raster land cover image. In fact, let's do that through the layers because that's quicker. If I use the layers pane, I could just click here to turn the layer off and on. And here's the raster layer. And you can see with pixels that are 10 meters in size, it's pretty darn good. It's not quite as precise as the drawing, which is right there, but it's pretty good. In fact, one reason the drawing looks crisper is because the drawing uses these black outlines, because the style for the drawing, it just uses a thematic formatting for the fill color, but it uses the black outlines for the black for the outlines. Let's thematically format the lines using the same thematic format as we did for fill color. And again, we're going to use the unique values, Tally. And again, I'm going to use the land cover palette, click reverse. And here again, I'm going to reverse these two, 2 and 16. There. Click Update Style. And now what we're doing is what I just did is I used exactly the same thematic format for the border lines as I did for the fill lines. So the border lines disappear. That makes them look like they're part of the the area, and that gives us a better, more comparable comparison to the raster land cover version of it. And as we click back and forth, you can see the raster version has some jaggies to it. So that was so fast to create the line that next time we're going to do this, we're going to use 5 meter pixels. We're not going to use 10 meter pixels because that will give us a lot smoother, because that'll give us twice the resolution here. So that's it. We've spent, if you exclude all the time we spent talking, it took us maybe 3 or 4 minutes start to finish to create an image and then do the join, because that's really the meat of the matter. All the rest of it is just explanations and illustrations of how to do thematic formatting and things like that. So as you can see, it's extremely easy to convert vectors to rasters and Manifold. The join dialog makes it easy. It's one of those wonderful dialogs that does a whole lot of things, so you'll need to learn one type of workflow and learn one sort of thing, and you can do a lot of different things with it. Thanks for watching. I hope you've enjoyed the video, and goodbye from Manifold Land. Well, that was fun. If you want to see more, visit us at www.manifold.net. As always, Manifold delivers the world's most advanced, highest quality spatial products for GIS and DBMS at a low price that you can afford. Once again, that's manifold.net. See you soon.